So hello everyone, in this video we are going to discuss the problem subarray removal, which is of today's contest. So the problem states that chef is given a permutation A of length n and chef can perform the following operation on A. Chef can select L and R and remove the particular elements from A of L to A of R, and we have to determine the longest such subarray, of which after removal of that subarray the rest of the elements will be a permutation. Let us suppose the given array is 213. Now we can remove this particular subarray starting from 323. Now this will become a permutation of size 2. Similarly for 1 2 3 4 5 6 7, we can remove subarray from this particular point to end, because after removal of this subarray the only element remaining is 1, and this is a permutation of length 1. And for 3 1 4 6 5 and 2, we can remove 3 particular elements, that is this particular subarray, such that after removal of this subarray the elements remaining will be 1 3 3 1 and 2, which is a subarray of size 2. We have removed a subarray of size 3, so answer will be 3. So we have to find the largest such subarray, after which the remaining elements will form a permutation. So moving on to the solution, let us suppose we are given array like 1 2 5 7 4 3 2 3 4 5 and 6. So it is pretty much sure that we have to remove the last element if our answer is suppose 1. So we can't remove any element from the middle, because let us suppose it is a subarray of size 7. So if we remove a element, let us suppose 3, so the array after performing the operation it will become this, and it is not a permutation because a permutation has all the elements from 1 to n occurring only one time. So it is of size 6, so it should contain all the elements from 1 to 6. It is not having the element 3, so it will not a permutation. So the only option here is to remove 7, because after removing 7 the array will become 1 2 5 4 3 and 6. See, you can see here all the elements from 1 to 6 all are present. So we have to remove the largest element. After that also we can remove the largest element. In this particular array we can remove 6, so after removal of 6 it will become 1 5 4 3, so it is a permutation of length 5. So the first observation here is that you have to remove the elements from highest and to lowest. Okay, so after the first observation, so 3 1 4 6 5 2, see here what we will do, and we have to remove the such elements such that it will form a subarray. We know that we have to remove this particular element 6 because it is of size 6, and we have to remove the largest element. Okay, so we have to start from this particular point. Right now we have to remove the next largest element, that is 5. Okay, we will remove 5 and it is forming a subarray. Now next element is 4, we will remove this particular element and it is also forming a subarray. It is a continuous segment. Now next is 3, we can't remove 3 because it is not forming a subarray. So what we can do, we will try to make such points which are occurred, and we will find whether it is forming a continuous segment or not. If it is forming a continuous segment, only one segment, then we can remove that segment, and that particular length of segment will be our answer. Let us suppose we have, let's clear this. Let us suppose we have 1 2 7 6 3 4. Here suppose it is 5, and it is 4 here. Now we will make this as occurred. We will make a array which will be shown whether the particular index has been occurred or not. We will start at the largest element because we have to remove the largest element from beginning, so we will make it as occurred. Now as it is occurred, so our segment is this point only. We have several points. We have 7 points here: 1 2 3 4 5 6 and 7. So we will make that this particular element has been occurred at this particular position. Now our segment number of segment is only 1. The next particular element is this, so this is corresponding to this. Now it has also occurred, so we know that we have to remove a segment from 7 and then 6 mid, and it should form a continuous segment. But now we can see that here 2 segments are forming, right? So number of segments here are 2, so this can't be our answer. Now after that we have to remove next largest element, that is 5. Now here we can see that this is one segment and this is one segment, so this is not forming only one segment, so it can't be considered in our answer. So next element is 5, next largest element is 4. So after 4 has occurred, we can see that this is forming a continuous segment and it can be considered in our answer. So answer can be this length, which is 4. Okay, the next element is 3. So this element, after occurring of this element, this complete segment is forming a one subarray, so the length of subarray can be our answer, that is 5. Now 2 is also occurred, and this is also making a complete only one segment, that is one subarray, so answer can be 6. So this was the approach of the problem. So for implementing it, you can use 2 pointer, like for 1 2 4 7 5 6 and 3. You can make 2 pointer, that is L, which will corresponding to this index 0 1 2 3 4 5 and 6. So first the 2 pointers L will be pointing to the largest element index, that is 3 here. So L and R will be pointing here. Now we will make that this particular element has occurred. We will make an array which will show whether the particular element has occurred or not. So we'll make this as occurred. Now we will move to the next, that is 6. So we will make a variable, that is component, which will show how many components currently in our segment are. Now 6 has occurred, so we will make has occurred, and now as its left and right are not occurred, so it will make a new segment. So we will increment our segment. Initially it was 1, so it will be increased to 2. Now 5 has occurred. Now whenever a number has occurred and its left and rights are already occurred, so it will merge that particular 2 segment into 1, so we will decrease the number of segment. Now 4 has occurred. 4 has occurred, so it is not doing anything because number of segments are same. Now 3 has occurred, it is also not doing anything. 2 is also occurred, and whenever our number of components is 1, we can increase our maximum size of subarray. I will show you the code how I has implemented this question. See, I have make occurrence array that will show whether the particular element has occurred on this index or not, and I have initialized a variable component that will show how many components currently in our array is, and from n largest element to the smallest element I am just counting how many components are there. See, I am taking the index of that particular element. I was at for 7 initially. I will take the index of that 7. I have stored that index in map. After taking index, I will find whether if it is a starting index or the last indexed, right? If this is our occurrence array, and suppose this is not occurred, and suppose this is occurred, so it will be increasing our number of components, right? So this is if it is occurred and its rights value is not occurred, so we will increment the number of components. Similarly, if its last index and its left value is not occurred, so we will again increment the number of components. And if let's its left and right is not occurred and this is occurring now, so it will also increase the number of component, and it will decrease the number of component only when its left and right are occurred and it is occurring, so it will merge the number of components and it will decrease the number of components. See, if occurred its left and occurrence of right is happened, then we will decrease the number of component, and if the component number of components is 1, we will assign the count of total number of values that has occurred till now, and at last we will print the number of maximum answer. So this was the solution of this problem. I hope you like it.